Okay, can you see?
Yes.
Okay, so yesterday we went through Spearman correlation. Today we are actually going through Kendall stove. Kendall stove is again a rank order correlation. So it's like any other correlation. So in the end, you are going to actually find the correlation coefficient, and it would be between 1 minus 1. So all those concepts really remain same in case of Kendalls. So only thing is, yes, it is. This is also something which is based on rank order, right? So Pearson is a quantitative data which can be much more richer as far as the calculations are concerned. We have Spearman in case of the ordinal. So now comes to the Kendall. Kendall is very similar, as I said, to Spearman. So then why Kendall? Right. So in Spearman, we talked about tide ranks, right? How exactly we are going to find the average of tide rank and all those stuff, right? So in Kendall, the concept of tide ranks is dealt in a better way when compared to Spearman. So that means when, especially if you have a scenario of tide ranks, then Kendall would actually fare better when compared to Spearman. Okay, so except that everything else really remains same. So when you have a non-normal data, which is not really a normal distributed data, you can't really use Pearson. If you have a smaller amount of data, then also the parametric test really becomes inefficient. So Kendall tau is something that could actually come into play when you are talking about something which is not a normally distributed data, which is an ordinal data. And especially if you have even more complex situation where you have a lot of tide ranks. Okay. So here it is slightly differently dealt as far as the way that you are going to calculate the entire tau. So in case of Spearman, it is called as rho. In case of Kendall, it is called as tau. Okay. So so first thing, right? So there are a few concepts that needs to be understood before we go into the how exactly these calculations are made. The first, see, entire Kendall is dependent on concordant and discordant pairs. So what exactly concordant pair? Okay. So concordant pair is, let's say you have a rank, you take the same example of the physics and mathematics that we are talking about, right? Okay, so if you see this particular, the way that, so this is student A, whatever that I'm highlighting, you're able to see that, right? So this is student A, let's say, and this is student B, whatever that I'm highlighting. Okay, so what happened in case of student A? Student A, when compared to student B's rank increased when I go down, right? When it comes to physics. But when it comes to mathematics, it is reverse. So when I travel from student A to student B, the rank decreased. So that means physics rank increased, mathematics rank decreased, right? So this is called as discordant pair. So basically in one subject it is increasing, in the other subject it is decreasing. Okay. What is concordant then? Okay, now take this student C, whoever is doing here, student C, and you take student D. What happened in case of student C? The rank in physics is 1. Student D's rank in physics is 6. That means rank increased. Whereas even in mathematics, is the rank from C to D increased. That is from 2 to 6, there is an increase. So this is called as a concordant pair. So basically, here both are increasing is concordant, both are, one is increasing, one is decreasing is discordant. Understood the concept? Okay. So I say, I take it as yes. So
So
concordant,
when there is an inverse, can we
yes.
say
Then
inverse? Yeah,
yeah, you can say it as inverse. So when there is an inverse, you can
and it's
say that it is
discordant.
a discordant. When you take it in the same direction, then you call it as concordant. If you are going in the same direction, it is concordant. If you are changing the direction, it is discordant. Okay. So there are multiple ways in which you can actually solve Kendall's tau. Okay. So there are three different ways. So I'll briefly give you a picture in terms of what those three different things are, but I will explain the easiest way out of all of them. Okay. So the first way is you calculate number of concordant pairs, you calculate number of discordant pairs. Okay. And based on that, you actually go and utilize the formula. So how do you calculate concordant pair and discordant pair? You will keep, so this is the example, right? I mean, I have a very short example where I have A, B, C, D. And in this, I have like, okay, yeah, A is having rank 1, B is having rank 2, C is having rank 3, D is having rank 4, right? And the same in case of, you know, rank Y, which is a separate subject, let's say mathematics here, I have 1 and I have tied ranks here, which is 2 and 2, and I have 4. Okay. So now, so what is, how do I calculate concordant pairs? So the pairs that are possible here, permutation combination, imagine what are the pairs which are possible? AB is one pair, BC is another pair, CD is another pair, AC is another pair, AD, BD. So all 6 possible combinations, right? So now I'm going to check, okay, what are the uh, combinations now, whether it is concordant or discordant. So when I compare A with B, right? The first comparison is A with B. Okay. When I compare A with B, so A is increasing. What about the, so basically here 1, 1, 2, 3, both are in the same direction. Yes. If there is no actually growth as well, it is actually concordant. Okay. So basically, if it is in the same direction, then you can actually say it as it is actually, in the, so basically you have 1 2 and 1 3, it is in the same direction, right? So it is concordant. When I see A and B's relation, it is concordant. So now when I see A and C relation, A is 1, C is 3, A is 1, C is 2, again it is in the same direction. That means AC relationship is also concordant. So now I compare A and D. A is 1, D is 4. A is 1, D is 4. It is in the same direction. It is the same values, right? So it is again concordant. So now I check B. Okay, so now there is no point checking B's relationship with A because it is already covered in AB here. So now with B, I'm going to check with C, right? 2, 3 and 3, 2. The direction is inverse. Now one is increasing, the other is decreasing. So hence it is a discordant pair, right? So net to net, what I am actually doing, I am just checking how many concordants are there, how many discordants are there. And based on that, there is a formula using which I can calculate Kendall's tau. This is one way. So this is easy when you have a lesser amount of data, right? I mean, imagine you have so 10, let's say instead of 4, you have 10. Then your table would really literally become large. So there is more simplified methods that are coming ahead. But this is one way of solving Kendall's tau. Okay, so I will not go into the other steps of this. I'll directly go into other alternate solution. Right, this is another alternate solution, which this is also something that I would not really explain in detail. The other alternate solution is you have A rank, you have B's rank. You can draw a line from A to B. matching the ranks, right? I mean, let's say you draw a line from 1 to 1, 2 to 2, 3 to 3, 4 to 4. So if you draw all the lines and calculate number of intersections that are happening, based on those number of intersections, there is another formula. Okay, so this is also a little confusing because you need to literally draw the lines and sometimes you might really miss the intersections. And if you calculate the number of intersections wrong, then you might really, so it really challenges your drawing skills. Sometimes the people like me, when they draw a line, we might actually get more than one intersection, even though it is only one intersection, because we can draw very, I mean, very much a parallel or perpendicular line. So so it is little tricky. So hence even this method for me looks little complicated. So I'm not going to practice this method as well. Now I'll go to the any questions till now? So to summarize, first method, you can calculate number of concordant pairs, number of discordant pairs. Based on that, there is a formula where you can calculate tau. The second way, you can draw lines and calculate number of intersections. Based on number of intersections, there is a formula that you can actually do. Okay, now there is a third alternative, which is the one which I literally prefer, especially when I have larger tables. So this, according to me, fare well when compared to the other two alternatives. Okay, so now what exactly this particular step is, right? So let's say I have the same table where I have ranks here, right? I mean, I have ranks where so I'm not really going into the first step of ranking it. So similar to Spearman, first step for Kendalls as well to actually find out the ranks. Here, tied ranks are going to be tied only. You are going to keep the same number. You are not going to do the average and all those stuff. Okay. And even if you do the average, it doesn't really matter because the method would really be agnostic to the tied ranks, the way that you calculate the tied ranks. Right. So now what exactly that I'm going to do here? Okay. So what I'm going to do here is I'm going to put these ranks in an ascending order. Let's say I have two ranks, practice session ranks and the competition ranks. So what I will do, so these are pairs, right? I mean, you can actually see that student A got first rank in practice session and student B got second rank in competition. So we are actually just comparing or correlating the ranks that a student got in practice session with the ranks that he got in the competition. Okay, so now we are actually, what we need to do, we need to put one of those, either practice session or competition, in an ascending order. Okay, so what it means, automatically competition rank will actually change, right? I mean, competition ranks might have a different order. If I put if I arrange these students in an ascending order, I arrange student A, student B, student C, student D, E, F, etc., in an ascending order of their particular ranks. Once I do this particular ascending order, automatically my competition ranks would align to it, right? So I will put same whatever the rank that student A got in a competition in accordingly. So once I put it in ascending order, I can put one of those in ascending order, and that's where the next set of steps really start. What is step 2 here, right? Step 2 is again about finding out how many concordant things are there and how many discordant things are there. Okay, so this is exactly doing whatever this particular method is actually talking about, but it is simplifying it in the way that you are actually calculating the concordance and calculating the discordant. Okay, so how it is really simplifying it? So how you are going to calculate number of concordance? I take A first. Okay, so now once I take A, what is the rank in competition here? 2, right? Anyway, the rest all the ranks, if I see practice session, they are in ascending. So there is nothing to be checked in practice session. Now my concentration of checking the concordance are not really, I'm concentrating on the competition ranks only. Okay, so now I take A. So now I have 2. as the rank. So now I'm going to check in rest of the students, how many students got rank better than A, how many students got rank lesser than A. So basically, if I see all greater ranks, that means from 2, whatever the greater ranks, I mean, if it is, so here I can see that 8 students got rank which is larger than whatever A's rank is. So that means number of concordant of A is 8. Number of discordant for A is how many students got lesser rank. It's only one student who got lesser rank, that is first rank, right? So discordant pair is 1. So now I take B. Okay. So now I take student B. I'll do the same exercise. Student B's rank is 1. How many people here got rank which is greater than 1? 8 again, right? So now 8 people got rank greater than 1. So how many people got rank less than 1? 0. There is no other person who is actually, lesser than 1 here. Now I take C. Now the C's rank is 5. Okay. So how many people got rank greater than 5? So you can see this. So concentrate on this. How many people got rank greater than 5? I have 5 students who got rank greater than 5. Okay. So now how many students got rank less than 5? So now I have 2 students who got rank less than 5. So that means number of discordant is 2. So similar exercise I'm going to do for D. So rank for D is 3. How many students got greater? 6 students. How many students got lesser than that? 0. Right? So this is the most important step as far as the Kendall stove is concerned. Please let me know in case if there is any doubt in it. Okay. So I'm repeating it again. What we are doing it first, we are actually arranging one of those particular ranks in an ascending order. And I'm going to check what is concordant, what is discordant for each one of them. Okay. And how I'm going to check concordant? I'm going to check how many ranks below this particular student has got more or rather larger rank than my rank, and how many students has got rank which is lesser than that, lesser than whatever the student that I'm comparing. So that would be the discordant. Okay.
So
So
here,
yeah,
the practice session ranks are already in ascending order. So that's why we don't have to touch the competition ranks.
practice session order is what you're going to order it, right? I mean,
No,
basically.
now here actually it is already in ascending order. That is why we don't have to jumble the competition ranks
Correct.
also. But
Correct.
in case you will say last I and J are reversed, like 8, 10, and 9.
Correct.
So
Then,
if these are like 8, 9, 8, 10, and 9 will become 8, 9, 10. So the ranks in competition ranks will become 8, 7, and 9 accordingly.
exactly. That's right.
Okay.
That's
So
right.
if at all the one pair of ranks are to be modified in ascending order, then we'll have to put those ranks, the second ranks list also according to the first one.
Exactly, because you are going to match rank
Match.
of
Correct.
student G with rank of student G only, right? I mean,
Right.
you are checking the G's practice session rank and competition rank. So you are talking about pairs here, right? So if you arrange practice session, you are arranging the students, not really the rank. You are just asking students, come on, students, stand in a line with your ranks in the practice session.
Okay. Right.
So you are arranging the students based on the practice session ranks. That's what exactly you are doing it. So your competition ranks would also move accordingly.
Okay. Yeah. Thank you.
Okay.
Praveen,
Yes.
Praveen,
Yes.
so Praveen, I had a doubt. Like,
Yeah.
what is the minimum size you need to apply this method?
Okay. So this doesn't have any minimum size. Okay. So because this is a non-parametric test, which is conducted on an ordinal data. So this is not a parametric test. So typically parametric test would have such limits. Okay. The non-parametric test doesn't have any limit to actually apply this particular thing. Having said that, right, lesser your data is, the chances of you having lesser accuracy. Because if you are just comparing 4 students and trying to say that, okay, yeah, I have a correlation, then you are doing a mistake because the sample size is less. But as a method, as a method, it doesn't really enforce any limit. Okay.
Yeah, thank you. And the other question that I had is, suppose someone, 2 children receive the same ranking, then?
Yeah, that is okay. Let them have the same rank. It doesn't matter. Right. For example, in this particular example that I have, right, I have 2 children with the same rank.
Right.
Okay.
Got it.
So you can arrange it in whatever the way that you would really want. Okay. So here it would not matter, because the moment you calculate concordant and discordant, okay, you are not really calculating the difference of ranks here. If you remember, if you compare with Spearman, so it would not matter, okay, whether you keep student B before or student C before, it doesn't matter. So in case if you are trying to arrange the students and you are thinking whether I should keep B before or C before because both has got the same rank, it doesn't matter. You can keep any one of those students. You will get the final result same.
Yeah, got it. Thank you, Praveen.
Okay. So did we understand on how exactly we were calculating the concordant and discordant? Okay.
1 second.
Yes.
In the first practice session, rank 1, the
Yes.
second is 2. Okay, the concordant is 8 because there are 8 more than the 1. 9 totally. More than the
Yes.
first one. Okay, so this concordant is 1.
Is
So when it
my
comes,
network bad or
no,
I'm not? I'm
I'm
not.
trying to analyze and say. So
No,
I'm
no,
going to
no,
see.
no. Okay, no problem.
So in the B second one, so in the B one, it is 8, right? You have written
8.
competition rank is 1, concordant is 8,
Yes.
right? So for more than 1, we will have 9, na?
No, can you see the highlighted rows?
Yes. Acha,
How
we will
many
leave
are
the
there?
first one.
Yeah, we are going to only check down. We are not going to
Okay.
check up.
Okay, okay. Got it, got it, got it.
So as we proceed, we are checking only down.
Okay. Clear.
So that is why you can actually see that you got the sum as only 6
Lesser
here.
number, yes. Less number,
So
yes. Okay.
it'll be lesser and lesser as you go.
Okay.
Okay. So now after this, once you actually put concordant discordant, it is pretty straightforward and simple, where you are going to add up all these concordants, which you call it as C. Okay. And you add up all these discordants, which you call it as D. And the formula is C minus D divided by C plus D. Okay. C minus D divided by C plus D. What is C? The sum of all the concordance, whatever that we calculated here. What is D? The sum of all discordance that you calculated here. And the formula is C minus D divided by C plus D. That's all. Okay. So the most trickiest part in Kendall stove is to calculate concordant and discordant. The formula is pretty straightforward. Okay. So once you get the result, we know how to interpret, because the interpretation is same as Spearman or Pearson or whatever it is, right? What we are actually seeing is it is positively correlated and it has got a decent correlation. I would not say very good, but it is nearly 0.7. That means it is almost, it is nearer to 1. So hence it is decently correlated, and it is a positively correlated, right? So that means you can say that competition ranks and practice ranks are positively correlated and it is decent enough. So once I'll give you one small example. We can probably solve it together, and then I think it would be more clear on how exactly these ranks can be arranged. So like yesterday, I'll just give a random problem by sharing the whiteboard, and we can probably, solve it together. Is it good?
Praveen, can you please give us something like, the first ranks also should be
Yeah, I will do
should be
that.
ordered,
I will
and
do that.
second one
That
is should be tied.
I will give a complicated example, because easy example in Kendall stuff is too easy. So I think,
Thank you.
okay, so let me just share the whiteboard. Okay. So I'll not give a lengthy example, but I'll give a little. Okay, now physics. Rank 2, 4, 1, 3, 5, and 6. Mathematics. So this is student A, okay? So he got E, and he got 2, he got 4, 1, no, 5, or rather I'll say 3, 3, 5, 6. Okay, so this is the example. Can we calculate Kendall stuff? The first thing is about arranging the candidates, right? So now what we are saying, this is student A, B, C, D, E, and F. Okay, can we arrange students now based on the rank of physics? Is somebody going to say how we are going to arrange?
1, 2, 3, 4, 5.
Let me just put first the numbers anyway. 1, 2, 3, 4, 5, 6. Right? So now in what order of students? Now tell me the student names. C,
A, D,
A, D,
B,
B,
E, F.
E, F. Okay, now what would be the mathematics ranks?
5, 3,
Right. 5, 3,
1,
1,
2,
2,
3,
3,
6.
6.
Correct, no?
Is it right? Anybody has got any objections or doubts?
No, no, no. It's the same.
Okay. So now can we calculate concordant? How many for C?
1.
So I'll put discordant as well.
Hmm.
How much? How many discordant?
4.
Huh?
Should we consider 3 and 3 as separate 2 ranks or 1 rank?
It is number of students who has got better or lesser rank than this.
4.
So it should be 0, right? That
Number of students who got lesser rank
Lesser.
than max.
4.
Lesser than
5.
2.
Why 2? See,
Fine.
greater than 5 is 6. So concordant is 1. So less
Right.
than 5 is
Sorry.
1, 2, 3, 3. So
3.
4.
4.
Oh.
4 is right answer. So whatever these candidates are lesser than 5. There are 4 students who got lesser than 5. Is it clear? Or any doubts here?
Okay, just to reiterate,
Yes.
we take the concordant and discordant based on the second. Physics, we have already put it in
We
the
have already,
proper order.
exactly,
So this is in respect to this maths one.
correct. So, and then we are calculating the concordant and discordant. Okay, so now, now tell me for A, how many concordant? Just see based on the students who are, how
One.
many are
That's
concordants?
one.
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 What about the discordant?
Okay, then we'll put two or
Two.
three.
2.
Two. You are not going to consider the equal ranks.
Three as it.
Mm.
Okay.
Okay. So now how many are for this
3.
filter? How many for discordant? Sorry. Discordant?
0.
0.
Yeah.
Yes. What about 5 and 6? No, what about the next one?
2 and
Uh,
0.
2 and 0.
0. Is it right?
Yes.
So last one is anyway 0 and 0. Okay, so now what is the sum of concordance?
1, 2, 3, 8.
7, 8. What is discordant?
6.
Okay. So one mistake that we did is when we are actually doing the concordant. Okay. So rank which is equal is also considered as concordant. So that means here the count is 2.
Hmm.
Are you getting my point? This 3 and 6 both are considered as concordant.
Greater than equal to.
Yes. So that means this C is 9, not exactly 8. Okay. So now what is the formula for tau? C minus D divided by C plus D. So that is equal to 9 minus 6 divided by 9 plus 6, which is 15. So that means 3 by 15. That means 1 by 5, which is 0.2. So it is positive, but very weak correlation. Any doubts in this particular Kendall stuff? Do we want to do it again or are we good? Are we good?
Yeah.
Yeah.
But I think practice will be needed. It's very easy to forget. It is as easy to remember as easy to forget.
Yeah, I mean, practice is required, but it is pretty straightforward as far as the entire
Yes.
procedure is concerned. It is a very short one. And this is also, I mean, so take it, one of the correlation, you will definitely get as 10 marks, whether it is Pearson or Spearman or Kendall stuff. And it might so happen that there could be two correlation sums as well. Okay, but it is like a short 10 marks question. If you actually do it, Pearson, Spearman, and Kendalls, if you remember that, that means like 10 marks is guaranteed. So there is no way that this sum is not going to come. Right? One of these are going to definitely come. It is like a short shot. Okay. So anyway, that's all as far as Kendalls is concerned. So if there are any, I mean, if there are any doubts, we can talk. Otherwise, we can conclude the class. I think people are clear.
Yeah, I think so. Thank you.
Yeah, I think you can stop the recording now. Ritika?
So when we are calculating concordant only, we should consider greater than or equal to,
Yes, that's
but for
right.
not for discordant.
Not for this. So once you calculate it in concordant, it is not available for discordant anyway, right? It can be calculated only once. That's right. You're going to calculate it as concordant and not really consider for discordant. Okay. So yeah, Ritika, you can stop the recording. I think somebody might have to give a call to Ritika.